So I talked about last time, there are basically two types of compounds. There are ionic compounds and there are molecular compounds. And the first thing you got to figure out is what kind of compound is it, because the way that you name them is totally different. So the way you figure out if a compound is ionic is it has either a metal or has one of those polyatomic ions in it. Then you know it's an ionic compound. The way you know if the compound is molecular is you look and see if all of the metals are nonmetals up in that top right, then you know it's a molecular compound. So go ahead and pull out your periodic table. We'll be using that a lot if you don't already have it handy there. So I said, so when you make ionic compounds, again, we have positive ions that are called cations, and we have negative ions that are called anions. And they always combine in some ratio that's going to give you a neutral compound. So I showed you, or I showed you on the last one, right? The one kind of way to think about this is with the crossover rule, which I said, which I almost hate to teach you because it only works taking the name and turning it into the formula. It does not work going the other way. So I have to be careful with that. So what I showed you were just taking cations, metals, and combining them with just monoatomic ions. But it works the same way with polyatomics, like sulfate, phosphate, whatever. If the charge is too negative on sulfate, we got to cancel that out with enough positives on the metals. So, for example, let's say we had magnesium and sulfate. So you want to make a neutral compound. Well, if you find a magnesium on your periodic table there, I think it's like number 12 or something. Somebody can check for me. And okay, magnesium lives in group 2, which we know means it needs to lose 2 valence electrons and become 2 plus. Sulfate is one of the ones you had to memorize. It's 2 negative. Okay, well, perfect. A 2 positive perfectly balances out a 2 negative, and you just put them right together. MgSO4. No problem. How about, let's say, potassium and chlorate? Okay, well, potassium. So you find that on your periodic table, and it's number 19, I think, or something. It's in group 1, which means it needs to lose 1 valence electrons. It's going to be 1 plus. So K plus. Chlorate's one of the ones you memorize. It's 1 minus. So again, perfect. A 1 plus perfectly bounces out a 1 minus, and it makes a nice neutral compound. So it's the same kind of deal. So you just got to balance out, right? So got to work out. Now, if they're not equal, again, so if 1 is 2 and 1 is 3 or whatever it is, well, we just use different combinations. The only thing we do slightly differently is if you have more than 1 polyatomic. So let's say you want to show 2 sulfates or 3 sulfates. Well, the polyatomic has to be put inside parentheses now. And I'll show you why that is. So let's say, for example, it was, and it's not loading for me, of course. Work with me here. Awesome. Let's say it was aluminum going with carbonate. Okay, aluminum. So let's just practice. Again, just find aluminum. We'll just pretend it's not, the charge isn't up there. Aluminum's in the magic triangle. It's in that group of 3. I said those 3 are all 3 plus. Okay, well, if you have aluminum 3 plus, you have carbonate 2 minus. Well, those don't balance out just 1 to 1, right? So you think about, okay, what's the least common multiple of 3 and 2? Well, I can put them both into 6. So the way to make a 3 plus into 6 is I need 2 of these, Al2. The way to make 2 negative into 6 is I need 3 of these. So I put CO3. But I can't just write I can't just write Al2CO3 3. Well, that kind of sucked. Try that again. Al2CO3 3. Why can't I do that?
It's like 33.
Because like 1 carbon, 33 oxygens. That's not what I mean. I mean I want 3 of the whole polyatomic. So I put the polyatomic in parentheses to show, oh, it's 3 of whatever is inside those parentheses. So again, whenever you have more than 1 polyatomic, you're going to put it in parentheses. If you only have 1, you don't have to do that. Just put SO4 or ClO3. If you have more than 1, we'll put it in parentheses. Okay. So let's just try a couple. Let's look at iron 3 fluoride. So, what's the symbol for iron? Fe. What's the charge on it? What is it? What? 3 plus. Because the Roman numeral right there says 3. This one here is easy. It gave it to you right there. So it's Roman numeral 3, so it's 3 plus. Why does that one need a Roman numeral? Because it's not in group 1, not in group 2, not in the triangle, which means it can vary. So they have to tell you what it is. Yeah, so iron 3. Okay, what would fluoride be? Well, fluoride probably comes from what? Fluorine. So find fluorine on your periodic table. Okay, it is 1 away from the noble gases, which means it wants to gain 1 electron, so it's 1 negative. Non-metals become negative. Okay, well, how do I make a 3 plus and a 1 negative balance out? What do I got to do? What kind of ratio? Yeah, right. So I need 1 iron and I need 3 fluorides. So I would write Fe F3. All right? So now it balances. So now I've got 3 of these negatives to balance out that 3 positive, and it balances out.
So you don't have to write the negative anymore?
No, it's gone. Yep,
Okay.
they're totally gone. Yep, now it's nice and neutral. So, are you with me? So I got 3 positive. How do I balance it out? Oh, I need 3 of these negatives, so I put F3. Yeah. If I only had 2, well then I would have 3 positive here, but then I would only have 2 negative here. I need 2 more for a total of 3, right? So if this is 3 positive, I need 3 negatives to balance it out. The way to get 3 is to have 3 of them. Okay? Okay, awesome. Let's try. Oops. I had another on here. Where'd the other one go? Okay, I guess I don't. Okay, well, so get out your hand out there. Hopefully you have. Let's just try a bunch. I'll do the first 5 or so with you, and you can do the next 5. So let's look at cadmium sulfate. So, again, grab your periodic table, find cadmium on it. Tell me first, what number is cadmium? Okay, based on where it lives, what's the charge on cadmium going to be?
2 plus.
2 plus. How do you know that?
It's in the magic triangle.
Yeah, it's in that magic triangle, right. And so the little group of 2, that's always 2 plus. So cadmium is 2 plus. What is sulfate? That's one of the ones you had to memorize. Sulfate is what? SO4 2 negative. Perfect. So how do I make cadmium 2 plus balance out with sulfate 2 minus? Yeah, I just put them together, right? Exactly. Yeah, exactly. Yeah. Just one of each, right? We'll do it. So that 2 plus balances out that 2 negative, and we're good to go. Right? Okay, how about lithium and carbonate? So find lithium and tell me what number it is so we can all find it together. Lithium is what?
3.
Number 3. So everybody find number 3. So, what's the charge on lithium?
Plus 1.
Yeah, 1 plus. Just plus. Because it lives in group 1, so it's 1 plus, right? Carbonate. Okay, carbonate's one of those ones you had to memorize again. So what's carbonate? Okay. So I've got a 1 plus and a 3 minus. Well, that's not going to balance out. So if I've got 2 negatives, well, I need to have 2 positives. So how do I get 2 positives? 2 lithium. So Li2 CO3. Okay, let's try the next one. Potassium hydroxide. So find potassium. Potassium's K. Where's the K live? Which number is it?
It's 19.
19. So it's in group 1, right? Everybody see that? So that means the charge is
Plus
1 plus. Yeah. What's hydroxide?
OH negative.
OH negative. Okay, so how do I make K plus and OH negative balance out?
You just put them together.
Put them together. Yeah. Awesome. Co, yes. Okay, cobalt 3 cyanide. What's what's the charge on cobalt?
3.
Oh, yeah, that's an easy one, right? Because it told you right there. Oh, Roman numeral 3, so I write 3 plus. What's cyanide?
Cn
Cn
negative.
negative. Okay, how do I make a 3 and a 1 balance out?
3 cyanide.
Okay, I need to write 3 cyanides. Why is that not the way to write it?
Because there's more than one polyatomic.
Pardon me? Yes, this one looks like 1 carbon, 3 nitrogens. I need 3 cyanides. What do?
Parentheses.
I put it in parentheses, yes. If you have more than 1 polyatomic, you got to put it in parentheses.
So the 3 shows that there's 3 of both of them.
3 of whatever is inside the parentheses.
And the cobalt too.
Whatever's in the parentheses. So that means there's 3 nitrogens and there's 3 carbons, because that's what's inside the parentheses.
Oh, okay.
The cobalt's not inside the parentheses.
That was just the charge. Okay.
Yeah. Okay. How about ammonium and iodide? What's ammonium? NH4 plus. Okay, if these are not rolling off your tongue, get on those 10 flashcards. Iodide. Okay, well, iodide probably came from iodine, right? So find iodine. What's the charge going to be on iodide? Oh, it's 1 away from the noble gases, so it's 1 negative. So I'll point out again, it's not -1 technically, it's 1 negative. Okay, so how do I make those balance out? Again, just put them right together. So NH4I. NH4I. Awesome. Okay, your turn. Find a neighbor. Try and do the next 5 on that sheet there. So help somebody out. Work together. See what you can do. Let's figure out first. Okay, what's magnesium? Okay, what's chlorate? And then put them together. Let's try a couple here. So let me just think about, so let's go through. Magnesium. Magnesium is in group 2, right? So it's 2 plus. Right? Chlorate, ClO3 minus. So I have a 2 plus and a 1 minus. How can I make a 2 plus and a 1 minus cancel out? So, well, if I need 2 of these chlorates, I need 2 of these negatives to balance out that 2 positive. So, how do I show 2 of those chlorates? What do I write? Mg, parenthesis, ClO3, parenthesis, and then a 2 out there I can't see. Yes. This is set in stone. I cannot change that. I can't suddenly make it ClO6 or 2, or I can't make it 2 negative, pull a 2 out of my ass. That's not how it works. Chlorate is always ClO3 negative. You can't change that. All I can change is how many ClO3s do I have. So if I have 2 of them, now that's 2 negative. That balances out the 2 positive. So let's try the next one.
So the negatives can fall off, though.
That's the whole point, is we're trying to get rid of all the positives and negatives and make it neutral overall. So now I gave myself 2 negatives, which perfectly bounce out the 2 positives, and they all go away, and now it's neutral. So that's the whole point, is trying to get all of the positives perfectly matched up with an equal number of negatives. So let's look at gold 3. Well, that means it's Au 3 plus, right? Okay, so we said sulfite, we just said, means it has 1 less oxygen than sulfate. So all I can change is how many golds I have and how many SO3s I have. Again, I can't change SO3 into something else or whatever, right? So I've got a 3 positive and a 2 negative. Well, those don't balance out. So, as I was saying before, Same before. Okay, think about it this way. Okay, what ratio? What's the least common multiple of 3 and 2? What do 3 and 2 both go into? 6. Okay, so how many gold 3 pluses do I need to give me 6? Oh, so I have 2 golds. That is now 2 times 3 plus. That's 6 plus. How many SO3 2 negatives do I need to get to be 6? 3. So I have SO3. I need 3 of them. But again, I can't write it like that, right? I have to put it in parentheses. Are you with me? So now I have 2 3 pluses. That's 6 plus. I have 3 2 negatives. That's 6 negative. So those balance out. Okay. Let's try zinc nitrite. So what's zinc? Zn 2 plus. Please don't say plus 2. That is an oxidation number. That is not a charge. We'll get to those later. Okay. Nitrite. Oh, ite. Ite means lost an oxygen. So what's nitrate? NO3 negative. So nitrite must be NO2, 1 negative. Okay, so I got a 2 and I got a 1. Well, 2 and 1 will both go into 2. So, okay, well the zinc's already 2, so I just need 1 zinc. To make the NO2 negative into a 2, I need 2 of them. So how do I write that? Parentheses, NO2. Perfect. So now I have 2 plus here, and I have 2 negative here. So the 2 plus bounced out the 2 negative. Okay, let's keep going. Lead 2 phosphate. What do I write for lead 2? What's the charge? What's the symbol?
PB2 plus.
PB. Lead 2 means 2 plus. Okay, what's phosphate? Oops, sorry.
PO4 3 negative.
PO4 3 negative. Again, that's one of the 10 you had to learn. Okay, so I've got a 2 plus and a 3 negative. So what do I need to think about doing here? Yeah, 2 and 3 both go into 6. So how many lead 2 pluses do I need to get me a 6? 3. How many phosphate 3 negatives do I need to get me into a 6? 2. So PO4, 2. Okay? So again, it's 2 of the PO4s. So I know sometimes students will go crazy and we're like, oh, PO2. They'll just change the 4 to a 2 and think that's how it makes 2 of them. No, the PO4 has to stay the same. You can have multiple PO4s, but don't change the formula. Don't change the formula. Okay. Cesium. What the heck is cesium's symbol in charge? CS.
1.
And it is. And then group 1, so it's 1 plus. What's acetate? That's one of the ones you had to learn.
C2H3O2 negative.
C2H3O2, 1 negative. Okay, so I have 1 positive and 1 negative, so that one should be easy.
So you put them together?
Just put them right together. CS, C2, H3O2. Perfect. So, again,
so you don't have to put parentheses.
Why do I not need parentheses on that?
There's only one polyatomic.
Right, exactly. Yeah, exactly. I mean, in this case, there's only 1, so there's no need to put. Yeah, only if you have more than 1, then you got to put in parentheses. Yeah, if you don't have more than 1. Right. Okay. Great. Okay, let's try some going the other way. So now let me give you the formulas, and let's figure out the names. So here's a little thing to keep in mind. The total of the cations has to equal the total of the anions. In other words, the total positive has to equal the total negative, right? So that's how you're going to figure out these charges. So let me give you an example. Let's look at Cr3N2. Cr3N2. So I'm going to write it here again. Write that a little lower. Cr3N2. So what is Cr called? What's the name of that?
Chromium.
That's called chromium. Find chromium on your periodic table. Which number is it? Which one?
24.
24. Everybody find it? It's number 24. Okay, it's not in group 1. It's not in group 2. It's not in the magic triangle. So what does that mean?
It has to give us the charge. So that would be like.
It means the charge varies. It can vary, right? It's not always the same. So that means we have to specify which chromium is it.
3.
Is it chromium 1? Is it chromium 2? Is it chromium 3?
3.
It's not chromium 3, by the way. So we got to figure it out. So we figure it out from whatever the other thing is. So what's the N called?
Nitrogen.
Well, nitrogen, but now it's an ion, so
Nitrate.
no. You see any oxygens with that?
No.
So yes, not nitrate. Nitrogen just all by itself. Yeah, those end in ide, we said. So fluorine, fluoride, chlorine, chloride, oxygen, oxide, sulfur, sulfide. Nitrogen by itself, nitride. So chromium something, nitride. So we got to figure out, okay, what is the charge on the chromium? We're going to figure it out because we know what the charge is on the nitride. So find nitrogen on your periodic table, and you can see how many it is away from the noble gases, and that tells you what the charge is on it. So
3.
it's 3 away, so yes, it's 3 negative. Every nitride is 3 negative. Everybody see that? See it's 3 away? So how many nitrides do I have, though? I got 2, right? In 2. I got 2 nitrides. So I have a total of 2 times 3 negative, 6 negative. Okay, well, this is a neutral compound. So if all of the anions are 6 negative, then all of the cations must be 6 positive. But I have 3 chromiums combining to give me 6 positive. So 3 times what is 6 positive? Each chromium must be 2 positive. So I write chromium, what? Roman numeral 2. So you got to figure it out based on whatever the charge on this is. So the anion charge is always known. You can always just know that. Either it's one you learned, like phosphate, sulfate, or it's right on the table. 1 away, 1 negative, 2 away, 2 negative, 3 away, 3 negative. Okay, so remind me again, real quickly, when do I use the Roman numeral? Why did I have to use it here for chromium? Because it can vary, right. It's not in group 1, it's not in group 2, it's not in the magic triangle, so therefore it has to have a Roman numeral. Yes?
Is this where you say we can get in trouble if we use the crossover rule?
Yes, going in reverse. Yes, so in this, so yes, that's what I'm saying. So in this case, it happened to work out where if you did the crossover in reverse, it happened to work out that it was 2 and 3, but that does not work half the time or more. So that's what I'm saying. So that's where it will bite you in the butt. So always figure it out and double check it this way. Okay, so let's try another one. So here's okay, let's do cinnabar. HGS. So this is a mineral called cinnabar. HGS. So, doesn't it? Sounds awesome. HGS. What's HG? Mercury. Find mercury on your periodic table. Number 80. Number 80. So does mercury need a Roman numeral? Why? Convince me. It's not in group 1. It's not in group 2. It's not in the what?
Magic triangle.
The magic triangle. Not just the triangle. It's the magic triangle. Okay, so we're going to figure out, okay, what's the charge? We'll figure it out based off this other thing. What is an S all by itself going to be called? Sulfide. Changes it to ide, right? Take the name of the element, and now that it's an ion, we turn it into ide. So sulfur becomes sulfide. So mercury something sulfide. What's the charge on sulfide? Oh, so find it on your table. Sulfur is 1, 2 away from the noble gases. Everybody see that? It's 2 away, so that means it is 2 negative. How many sulfides do I have, though? I just got 1. So I have a total of 2 negative, which means the total of my positives has to be 2 positive. And I only have 1 of them, so that 1 mercury must also be 2 positive. Yeah, so I'm showing you like a little system here with my little writing above, below arrows, so just follow me along here. Okay, so it's mercury, 2 plus, so I write mercury, I. Whoops. I'm going to use my blue again. Mercury 2 sulfide. Okay, let's do a bunch together. Okay, so let's do a few more here. K2CO3. What is K? Okay, does potassium need a Roman numeral? Why doesn't it? Mercury did, chromium did. Why doesn't potassium need a Roman numeral?
Because it's in group 1.
It's in group 1, which means it doesn't ever vary, right? So there's no reason for you to tell me potassium 1 or whatever. It's always 1. Okay, so that's easy. What's the CO3 called? Carbonate. There you go. You just named it. Potassium carbonate. Name the cation. Name the anion. Potassium carbonate. Yeah.
So for us to name it, the equation that you give us would already have to be balanced.
Oh, yeah, sure. Here, the formula. Yeah, exactly. It's already neutral. It's already a neutral compound. Yeah, definitely. Okay, how about this one? CO, parentheses, ClO3, parentheses 3. So what's CO? Cobalt. Find cobalt. Does it need a Roman numeral? Now, why? Where's it at? Which number? It's 27. So why does it need a Roman numeral? It's not in group 1. It's not in group 2. It's not in the magic triangle. I know I'm saying that a lot, but I'm going to say it 50 times if I have to until it drills into your brain. So if it's not in group 1, 2, or the triangle, yes, it needs something in parentheses here. What's ClO3 called? Chlorate. Next question. What's the charge on chlorate? You had to memorize it. It's 1 negative. 1 negative. How many chlorates do I have, though? Oh, how many chlorates? I heard 3 and I heard 9. I have 3 ClO3s. So 3. So I have 3 negatives. So I have a total of 3 negative, right? I have 3 of these 1 negatives. So I have a total of 3 negative. So if all of the anions are 3 negative, all of the cations must be what? 3 positive. But I only have 1 cobalt, so that 1 cobalt must be 3 positive. So I would write cobalt what? Roman numeral 3. Cobalt 3 chlorate. So we can always figure out the charge on the cation by knowing what the charge on the anion is. This is why I asked you 2 weeks ago to start learning these, because it's going to save you, give you a nice heads up here. Okay, so let's look. Get out your handout there, and I'll do the first 5 again with you. Then you guys can try the next 5. So NH4Cl. What's the cation in this? Yeah, the cation is the NH4, which is called ammonium. That is one of the polyatomics. So you don't need a Roman numeral, of course, for that. It's not a metal. What's Cl all by its lonesome called when it's an ion? Chloride. Yes. Yes.
That's because it's a non-metal.
Yes. All of the nonmetals, when they are, all the nonmetals, when they're acting like an anion, they're by themselves. Just change the ending to "ide." All right? By themselves. Now, again, if they're with oxygens or things like this, or whatever, now they have their own special names you had to memorize. But just by itself, so just the chlorine, just the nitrogen, just the sulfur, that's when you make them "ide." Okay, good. Ca and that other big messy thing. What's Ca? Calcium. Does calcium need a Roman numeral? Why not? It's number 20. It's in group 2, right? Everybody see that? It's in group 2, so the charge doesn't ever vary. So there's no reason then for you to specify what it is. So what's that other big thing called? Acetate. Calcium acetate.
That's all you need.
That's it. Okay, let's try the next one. What's Cu? Copper. Does copper need a Roman numeral? Which number is copper? 29. Why does copper need a Roman numeral? Calcium didn't.
Not in one, not in two, not in the golden triangle.
Not in one, it's not in two, it's not in the magic triangle. I think the golden triangle, that's where they used to sell like heroin from, the golden triangle. All over Southeast Asia, they have the golden triangle. Different triangle. Okay, so we're going to figure out the charge on copper because we know what the charge is on that NO3. So what's that NO3 thing called? Nitrate. And you all listen to me so you know the charge on nitrate is.
3 negative. 1 negative.
Yes, every nitrate is 1 negative. How many nitrates do I have?
2.
2 of them, so that's a total of 2 negatives. So if the negatives are 2 negatives, all the positives must be 2 positives. And that's my little system here. I'm telling you, just follow along and write it with me. Because what I have to do is the long way. You sure as heck need to practice to do it the long way. So just follow me. Okay. Oh, but how many coppers do I have? I just got 1 copper. So that 1 copper itself must be supplying the 2 positive. So copper 2. Okay. Going to erase this.
So
Yes.
essentially, you can once you find the charge for the one in parentheses, or basically the next thing, you can just multiply that charge by whatever's outside the parentheses, and then that's how many 2 negatives, let's say, are at the bottom, right?
Okay.
And then that same number will be on the other side, just positive.
Right. That'd be the same,
Multiply that by however many there are for the top. So multiply like 2 plus
Well,
1.
divide this by however many there are.
Oh, yeah.
Right? If there was 2 of these, then each would be 1.
Yeah.
Right, yeah. Yeah, exactly. Okay, let's try the next one. What's Be? Beryllium. So find beryllium on your periodic table. Does beryllium need a Roman numeral?
No.
Why not?
It's in group 2.
It's in group 2. Everybody sees that. Everybody find beryllium? It's like number 4 or something. Okay, so no Roman numeral, right? Okay, what's ClO2 called? Ooh, I heard 8 and 8.
8.
Yeah, ClO3 is chlorate. This is apparently lost in oxygen, so it's chlorite. Ite? Ite. Ite? Ite. Okay, chlorite.
We got 2.
We don't need to do anything else. We're done because there's no charge. I mean, on beryllium, it's always set, right? So there's no reason to figure it out or whatever. Okay, how about the next one? What's Sn called?
10.
10. So find 10. Does 10 need a Roman numeral?
Yeah.
Okay, which number is 10? What is it? 50. Is that what it is? I don't know. Okay, 50. Number 50. So does that need a Roman numeral? Oh, I heard yes and no.
Yes.
Or no.
It's.
4 negative.
Is it in group 1?
Well, no.
Is it in group 2?
No.
Is it in the magic triangle?
Needs parentheses.
It needs a charge.
Didn't you say for these?
Non-metals.
And for Cn.
These up here are the non-metals.
what is that,
Everything on
cyanide?
this side's a metal.
Cyanide is cyanide, right?
This is on this side, right? This is a metal.
Yeah.
Right. Oh, okay, so it's just these that could be the the 1 negative.
Just the non-metals, yeah,
Okay.
which are up here. All the metals, all these are all positive. Okay, so let's figure it out. What's that Cn thing called? Everybody's favorite. Cyanide. Okay, let's figure it out. What's the charge on cyanide? It's 1 negative. How many of those cyanides do I have? 4. So I have 4 negatives, which means I must also have 4 positives. And I only have 110, so that 110 must be supplying the entire 4 positive. So I would write 10. How do I write 4 as a Roman numeral?
1B.
IV. 10-4 cyanide. 10-4, good buddy. Okay. Okay, your turn. You and your neighbor try the next 5. So what's zinc? Where's it on the table? Does it need Roman numeral or not? Figure all that out, right? Talk it with your neighbor. Help each other out. Okay, so we already said that was zinc carbonate. What'd you get for G?
Strontium nitride.
Strontium
Nitride.
nitride. Nitrogen all by itself, nitride. Okay. Next one's a little sneaky, so I was going to work it out here. So, manganese. Okay. Manganese. It does need a Roman numeral because it's not in group 1. It's not in group 2. It's not a magic triangle. Combined with sulfur. So sulfur is by itself, so that means it's named sulfide. What's the charge on sulfide?
2.
It's 2 away, so it's 2 negative. I have 7 of those 2 negatives, so that's a total of 14 negatives. Which means all the manganese must be 14 positive. But I have 2 manganese. So 2 times what is 14 positive? It's like you asked me, take that and divide it by the number there is. So 14 divided by 2, each one must be 7 plus. So Roman numeral 7, VII. Okay, how about the next one? What's AG? Silver. Does silver need a Roman numeral? Why does it not need a Roman numeral? It's in the magic triangle. What's oxygen all by itself going to be called?
Oxide.
Oxide. Oh my gosh. Slowly sinking in. Awesome. What is Fe? Iron. Does iron need a Roman numeral?
Yes.
Yes, it's not in group 1, 2, or the magic triangle. What's that OH thing called?
Hydroxide.
Hydroxide. So iron something, hydroxide. What's the charge on hydroxide?
Negative. 1 negative.
Negative, or 1 negative. So I have 3 of them, so that's 3 negatives. So all of the irons must be 3 positive. How many irons do I have? Just 1. So the 1 iron must be 3 positive. So iron 3 hydroxide. Okay, let's try a couple more. Just going to make a couple up here real quick because I'm going to do a few other. Let's try. How about this? Try it out. Wow me. Impress me. Okay, compare with your neighbor or somebody around you. Find somebody.
-2.
I think we're gonna
Negative tungsten 6 sulfite.
Okay, let's do it. So W is tungsten. Heard people saying that. Of course, that needs a Roman numeral because it's not in group 1, 2, or the triangle. What's SO3? Sulfite, right? Sulfate's SO4. This has one less oxygen, so sulfate becomes sulfite. Awesome. What's the charge on sulfite?
2 negative.
2 negative, same as sulfate. But I have 3 2 negatives, so that's 6 negative. So this must be 6 positive. I've only got one of them, so that one tungsten must be 6 positive. So tungsten 6, Vi. Tungsten 6 sulfite. Okay, one more. Let's try. Okay, name that for me.
Nickel.
Don't spell nickel wrong.
Nickel.
Yes, it's nickel. It's not Nicola. E-L, not L-E. Nickel. Figure up the charge on the carbonate. Oh, wait a minute. There's a mistake on that, isn't there? There's going to be fractions. I just realized. You're all like, wait a minute. Let me see. This should be, let's try the other way. Let's try this way. Let's try that. That'll make more sense. I'm sorry. You're all like going crazy. Is there a fraction? And I'll give you one more when you're done with that. There are fractional charges actually, but we won't do those in this class. They're not really actually fractions, kind of like shared among multiple atoms. Okay, did you talk it over with somebody? Do you agree? Okay, let me go over it. So what's nickel, Nickel, something, right? You got to figure it out because nickel's not in 1, 2, or the magic triangle. So nickel something, and that's carbonate. Oh, ran out of room. That's supposed to be an E on the end there. Sorry. What's the charge on carbonate? 2 negative. There's 3 of them. That's 6 negative. So these must be 6 positive. 2 times what gives me 6 positive? 3. So nickel 3. This one, what's U? Uranium. Uranium's definitely not in 1, 2 of the triangle, so it needs Roman numeral. What's PO3? Phosphite. Phosphate's PO4. This has 1 less oxygen, so phosphite. What's the charge on phosphite? 3 negative. There's 2 of them, so that's 6 negative. So again, these are all 6 positive. But I only have 1 uranium, so that 1 uranium must be 6 positive. So uranium 6, Vi. Okay, here's my very strong encouragement to you. Practice this between now and Tuesday. Because it's sort of making a little sense now. But if you just don't think about it at all for the next 5 days, you'd be like, how the crap was that working last Tuesday in class? So we still have 15 minutes left. I'm just saying, so, tonight or tomorrow, go do a little homework on it, right? Watch the YouTube videos on it, actually. The YouTube videos on this, I feel like, are really excellent on teaching this. Go back and watch my little YouTube videos I made together. So yeah, watch the videos. Like I said, do a little homework, reinforce it, but do not just, I'm free till Tuesday. Now think about it, else you will be torpedoed when you come back Tuesday. So trust me, you need practice. You definitely need practice. Okay, so now, forget everything I just taught you. Done. So now we're going to name molecular compounds. That was the rules for ionics. Molecular, totally different. Totally different. But they are really easy. So molecular compounds, I'm going to show you how to name those in 5 minutes. They're really easy. So first off, how do you know if a compound is molecular? Yes, the elements are all nonmetals. There's 2 nonmetals. Where do the nonmetals live again on the chart there? On that top right. So if all the elements are up there, so if it's carbon and oxygen or sulfur and chlorine, then it's molecular, right? So all the ones up to now, we either had a metal or we had a polyatomic, which made it ionic. Okay, so all you do to do this is first you name the first nonmetal. Then you take the second nonmetal and you change it to "ide." So let's say it's CO2. That's one everybody knows. CO2. Carbon and oxygen are both nonmetals. They're both up there in the top right quadrant. So I would just say carbon. Second one, I would say oxygen oxide. And then all I'm going to do is I'm going to put a little Greek prefix to tell me how many I have. So di is 2, so carbon dioxide. So here are the 10 Greek prefixes you need to put in your brain. So I will pause for 20 seconds. That'll give you 2 seconds to write each one down. One is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 is hepta, 8 octa, 9 nona, 10 deca. Now, most of these you probably already kind of know, penta, a pentagon, a pentagram is 5. Octa, like an octopus, 8. Hexa. The weird ones are like hepta, nona, deca. Those you probably don't use very often. So I was teaching this probably been 2 or 3 years ago now, back at Fresno City College. I'm in that one class. I happened to have 3 students from Greece, so they all spoke Greek, and they all laughed at me on number 9, because I guess the rest are all really right, they were all like laughing. I was like, why? And they was like, oh, well, Nona in Greek actually means godmother. So it's like 7, 8, godmother, 10. They're like, oh, why is it Nona? I'm like, I don't know. So, but the rest are right. So I was thinking that, 6, 7, 8, godmother, 10. So, okay, so now the only little extra rule is we don't use mono if the first one's 1. So you don't say monocarbon dioxide. You just say carbon dioxide. But you do use it if the second one. So let's say it's CO. Well, that's carbon monoxide. You do say it if the second one is only 1. So the only other little thing to throw out there at you is we don't write monoxide. We do actually combine these. Whoop, just make it monoxide. We don't write both O's. But that is the only time we do that. Every other time, if it's 2 I's together or for 2 A's together, that's fine. Leave them both. We only do that for monoxide. Okay, so that's it. It's pretty easy. So all you do is you name the first one, put a prefix. Name the second one, put a prefix, change it to "ide." You're done. So let's do a few here, and you'll see they're really easy. P4S3. What's P? Phosphorus. Not O-U-S, by the way. U-S. So what's the prefix for 4? Did I just show you? 4 is what? Tetra. So tetra phosphorus. What's S? Sulfur, so I make it sulfide, right? So something. And how many? It's 3. So what's the prefix for 3? Tri. Tetraphosphorus, trisulfide. Again, this is much easier than the ionic way. So I can show you so quickly. Just wish they were all that easy. Tetraphosphorus, trisulfide. Okay, how about this one? How about N2O4? So, I need to say, 2 nitrogens. How would I show 2 nitrogens? Di what? The first one keeps the original name, so dinitrogen. The second one goes to ide. So 4 oxygens, tetra oxide. And again, keep both the vowels here. Keep the A and the O. Just the mono oxide, do you smush them together and make monoxide. Okay. Let's try a couple here. NO2. What would NO2 be? Now, so I have 1 nitrogen, but I don't use mono on the first one. So I don't say mono nitrogen. I just say nitrogen. And then 2 oxygens, right. Nitrogen dioxide. How about PCl5? Phosphorus. What is it? Pentachloride. Let me get the nice, neat printing rather than my handwriting. Okay, your turn. Try C, D, and E. Try those. Okay, talk it over. These should be pretty quick now. These are a lot easier. Okay, let me go over these with you. So, I2F7. So, how would I say I2? Diiodine. Yes, you do keep both I's, even though I know it's wacky, but I said it's only the two O's you get rid of one. So, diiodine what? Heptafluoride, right? Not fluoride. Did you put OU? Smack yourself. It's fluoride. There's no flour in fluorine.
Is it all double O's or is it just with monoxide?
Monoxide. Yeah, that's the other one. Yeah. How about SB3Cl9? Triantimony. Godmother chloride. Yes. Nona chloride, according to my Greek friends. Yes. Godmother chloride. Yes. Now I'll point out though, SB. If you find it on your periodic table, it's a metalloid. It's not really a nonmetal. It's not a metal. It's a metalloid. So I told you metalloids, are kind of like this hybrid between metals and nonmetals. And even their naming scheme is a hybrid. It's your choice. So that means since it's in the middle, you can name it like an ionic compound, which would be antimony 3 chloride, or you can name it like a molecular triantimony nonachloride. So yeah, that's one I warned you. So it's really, that one's not, it's a metalloid, it's your choice. P408. P4. Tetraphosphorus octaoxide. Isn't that a weird one to say? Tetraphosphorus octaoxide. Okay, so we got 3 minutes. So I know you're dying to get out of here. But, so just real quickly, let's just do them just the other way. Real quick. So dinitrogen tetraoxide, because just figure them out real quick. It should be quick going the other way. So dinitrogen tetraoxide. What's that mean? Disulfur hexafluoride. What's that mean? Yeah, dinitrogen tetraoxide. N2O4. Okay. Sulfur hexafluoride. What's hexa? Six. So what is it?
SF6.
SF6. Good. Diarsenic. What's arsenic's symbol? AS. So di means two of them. AS2. Trisulfide.
S3.
Okay, S3. Diselenium monoxide. SC2. Oh, good. And pentanitrogen nonachloride. N5. CO9. Okay, well, before you leave, I just want to remind you one more time. Practice this between now and Tuesday. If you want to have any hope of passing this chapter of this class, please practice it. Also, I want to point out